Hi everyone, welcome to this video on lesson 12 of the atomic structure and periodic table scheme of work. This lesson is on the modern periodic table, so it comes hot on the heels of a lesson on Newlands, followed by a lesson on Mendeleev. And actually, in that lesson on Mendeleev, we hope that students have really got the idea of what the periodic table is trying to achieve, so that this lesson is really about them getting to know their way around, really becoming familiar with that periodic table so that they can use it in the subsequent lessons where we bring together the structure of the periodic table and how the elements are organized within the periodic table, and all the work we did on electron configuration and ions and all of that business. First part of this lesson, I'm not going to do a video on this because I've done a video elsewhere. It's something that we did in year 7, which is going through the periodic table. I think it's fine to go through it again. I think it's important enough that it's worth just revisiting that with students, but I won't go through it in this video. But essentially what we want to get is something like this. You can use highlighters instead of pens, whatever works best for you. But drawing their attention to the fact that metals are over here, these are the non-metals, and this block in the middle, which we'll come to in a later lesson in the scheme of work, those ones in the middle are the transition metals. And you can talk about group number and period number there, but what we really want is not just that they can tell you, okay, the groups are columns and the periods are rows. I mean, we kind of want them to tell us that, but what's really important is that they can use that. So this second half of the lesson, I'm just going to go through the 3 worked examples that you'll find in the slides. And I've drawn them out here in my book. Probably, I would say throughout this scheme of work, you want to keep revisiting, keep going back to basics. You might even want to start, rather than with the name of the element, you might even want to start with CL 1735 or whatever it might be. And get students thinking, PNE, okay, how many electrons are there? All right, if there's 17 electrons, how am I going to draw the structure? Maybe get them to do that on whiteboards as a prereq check, because throughout this scheme of work, we want to just keep going back to first principles and building up this picture of how to think about chemistry. And what you find is throughout the whole course, all the way to the end of year 11, if they keep coming back to these basic concepts and these basic ideas around how atoms are structured, then they've got a really good chance of being able to understand what's going on. But once you've got there, and you know, it doesn't matter how you do it, you can do it on the slides, get them to do it on whiteboards, however you feel. But once you've got to this point where they've got the electron configurations and so on, really all this is about just reminding them what we mean by period and group number, just so they're familiar with that and they can relate that to the periodic table. And all I'm going to do, this is quite simple now, but it's just to say, well, okay, period number, that is just the number of shells or the number of energy levels. So I'm going to say, well, how many have I got here? 1, 2, 3. So this must be in period number 3. So far, so simple. And again, you might want to get them to do this on whiteboards. You might not even need to do a kind of I do modeling this, because if you've explained it in the previous part, they might be able to recognize it. But it's important that we go through it one way or another, just to make sure they're familiar. So then the second part, again, whether you want to do this yourself first or just go straight to whiteboards, that's fine. But the next part is to say, well, okay, when I'm looking at the group number, I'm going to the very last shell and I'm seeing how many electrons are in the outer shell, and you can either count them on here or you've written it down here. That's going to be group 7. And what's really important here is that you don't just stop there. You then go back to your periodic table and say, well, should we just check that we're correct here? So if I look over here, and I'm going to have to zoom out a bit. Okay, so I said my group numbers were here, and my period numbers were down here. So we've said this is in period 3, chlorine. So I'm going to count here 1, 2, 3. Now, they often forget that this is period 1. They often think that this is period number 1 here. So again, this is a really good chance to remind them of the fact that the first period only has 2 elements, hydrogen and helium. So period 1, 2, 3. Okay, and then I'm going to have to go across to group number 7. So I'm going to go, right, I'm looking at these numbers and I'm on that row here. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Is that chlorine? Yes, it is. Perfect. So you can just model that to students and get them familiar with that. So again, you can do the same thing here, and this is where, by this point, I think you would hope that they've got the hang of it. So you can get them to start thinking about this on whiteboards. Again, the main thing to look out for here is that they're not mixing them up. So in this case, Some students might say this is in period 5 because it's got 5 in the outer shell. You need to remind them, no, it's in group 5, it's in period 2 because it's got 1, 2 shells. So I'm going to put period 2, group 5. And again, I'm going to go back to my periodic table and I'm going to check. I'm going to say, well, period 2, that's 1, 2. Group 5 is 1, 2, 3, 4, 5. Okay, great, that's nitrogen. The ones that students find tricky are ones like magnesium and maybe boron, because they get the period and group mixed up. So they might think, boron, so that's going to be period 3, group 2, something like that. That's wrong, and you want to make sure that they don't make those sorts of mistakes. So this is why modelling it is really helpful. And again, we could do the same here. So silicon is going to be period 3 because it's got 1, 2, 3 shells, and it's going to be group 4 because it's got 4 in the outer shell. And again, you can go back to the periodic table one last time and just show that. So we've said 1, 2, 3, and then group 1, 2, 3, 4. Hey presto, there is silicon. So it's worth modelling that. It shouldn't take you too long, but it's really good for students to get some practice at that. And again, it just takes them beyond being able to give you a definition that they don't really understand. And actually, through using these ideas around the periodic table, that really stimulates them to think about it more and hopefully remember it more. And it's going to be really, really valuable when we get to the next lesson and we start looking at trends within the different groups in the periodic table, starting with the alkali metals.